Hi, this is Anjali. I'm going to start my first video on probability. In this video, we are going to discuss some short history of probability. Then we will discuss about the basic concepts of probability, like what are the random experiment, sample space, and event. Do you know origin of probability is gambling? Yes, in 16th century the gambling was so popular and fashionable, mostly in French society. The famous gambler Chevalier de Mere lose his money in his game, so he was curious about why he is losing so much money in game. He approaches to Blaise Pascal. Blaise Pascal was French philosopher and mathematician. Blaise Pascal and his friend Perry Farmer solved the problem of chance of winning of game, and this contributes the mathematical study of probability. This method is nothing but the classical approach of computing probabilities. Now we will see what are the random experiment. Daily we perform lot of activity in our life. The corresponding any activity outcome may be fixed or not fixed. Some activities are so deterministic. Suppose we consider any chemical reaction, the result of this chemical reaction always fixed. So these experiments are not a random experiment. The, suppose we consider a experiment of tossing a coin, then we will get either head or tail. We are not sure that in the first trial I will get head or tail, right? So we are not getting fixed result here. So this now I am giving one exercise for you. You have to do this experiment to understand the random experiment. Pour water into a glass and observe that bubbles would appear in the glass, and count the number of bubbles appear in the glass. Perform this experiment 5 times and note down the number of bubbles in each time. So explore what you are getting from this experiment, and also conclude that the experiment is a random experiment or not. Now we will see what is sample space. Sample space is nothing but the set of all possible outcome for a random experiment. We will see example so that you will get what is exactly sample space. Consider experiment tossing a coin. So here we are tossing a coin. So we will get head either or tail. So that's why here we have listed all possible outcomes as a set S. So sample space is denoted by S. Then second example we will see when tossing a coin two times. So here we are tossing a coin two times. So first time we may get head. Then second time we may get head. Or in the second possibility we will get first time head, second time tail. Or first time tail, second time head. And the last possibility is both we will get tail. So all these possibilities listed in the set of S as a sample space. Then third example of rolling a dice. So when we are rolling a dice, we will get the six possible outcomes. So these are the numbers of dots on dice. So this is denoted by S, and which is equal to 1, 2, 3, 4, 5, 6. So event is nothing but a subset of sample space. So I will write in definition, event is a subset of sample space. So in earlier example, so these three experiment we will take. First experiment is tossing a coin. Second experiment, is tossing a coin two times. And third experiment, rolling a die. So here I will define my event A. So event can be defined by A is getting a head. Then, so sample space, my sample space is, so for this, my sample space is head and tail. So for A, I can write only head, right? For then second example, suppose my A I have defined getting exactly two head. Then my A will be only one element because I want exactly two head. Then rolling a die, I will define my event. So it's mostly in question, it is defined and you have to check what element are coming. Means this A is defined in the question, like what is event, and you have to prepare this set of event, what element will be there, and you can calculate the probability on the basis of that. Okay. So here I will define in third example, event A is equal to the number of dots appears on die are multiple of 7. So now tell me if my sample space is 1, 2, 3, 4, 5 and 6. Then for A there is nothing. So I can define A as a empty set. Also it can be written by 5. Right? So this is my empty set. This set also known as impossible set. Also, suppose I will define my event B as a the number appears on die is less than 7. So 1, 2, 3, 4, 5, 6 all are less than 7. So my B is nothing but 1, 2, 3, 4, 5 and 6. So this is nothing but my S. So whenever event is equal to sample space, then you can say this is your sure set. Thank you for watching. Don't forget to like, comment and share. Please subscribe and click on bell icon so that you will get all notification of my videos. Also, in the next video, I'm going to discuss classical approach of probability, axiomatic approach of probability, and few example on computational of probability. So thank you. Bye bye. See you.